Hello guys, here is one interesting problem. Let us read that out. A machine gun is mounted on the top of a tower 100-meter high. It fires bullets at an angle of 30 degrees with the horizontal. So angle of projection is given. Find the maximum height that the bullet reaches, the time to hit the target on ground, and the position of the target it can hit. So what do they want us to find out? Number one is maximum height. Now when they say maximum height, it would be the height, maximum height above the ground, right? The gun is mounted on top of this tower, that is okay, but then when they say height, it would be measured from the ground. Number two is the time to hit the target on ground. Okay, now see, it is very important that it's not surface to surface, it's the gun is mounted on top of the tower. Correct. So from there, it's going to something like this. The tower is here. Okay, this is my ground, and this is where the gun is mounted. Okay, and it's going to fire this bullet like this, and maybe it would move like this, and this is your ground level. Okay, this is your initial speed, direction of initial velocity here, and this angle is theta, and that has been given to be 30 degree. You have the speed of bullet, it is 150 meter per second. So u is given, you have the angle, and you need to find this distance. Okay, you have been given that the height of tower is 100 meter. This is something which we have not seen before, because we have seen that my bullet or that football or whatever is my projectile body, it starts from the ground, it lands on the ground, but now here it is starting from the top of this tower and it is going to land on the ground. Correct. So there is something different here. Now if you extend this line here, what is this point? So if I treat this as my ground, correct, then this is my ground level, which actually is not. Okay, but then there are ways of solving the problem. Okay, what can we do? Now we know that we are going to have only gravitational acceleration, no acceleration in the horizontal direction. Correct. So my speed in the horizontal direction, which is going to be u cos theta, it is going to remain constant. It is not going to change. My speed, my vertical speed is going to change, right? My vertical speed will become 0 at that maximum point of maximum height there. Okay, and what about my vertical speed after that? It is going to start increasing in the downward direction. Okay, now this is going to land here. Now if you see this point O here and my point A, I always take A as my landing point, okay, and O as my starting point. Now here maximum height point is going to be B, and I'll call, for a change, I'll call this point C. I used to call that point as A, but now I'm calling that point as C, because A is the point where it is going to land on the ground. All right, now if I see what is my vertical displacement when it lands on the ground, is it not 100 meter below the starting level? Isn't it? It is. So but then that 100 meter is below my starting point, so I'm going to take that as negative. Correct. So we can find out the time. Okay, so if you think of vertical displacement, displacement from O to A, right? So my displacement, vertical displacement is minus 100, right? What about my initial velocity here? Initial velocity would be 150, and so initial vertical velocity u is equal to uy, I would say, is equal to u sine theta. So that is equal to 150 into sine of 30 degree, that is equal to half, that is 75. correct? Now what? Now my S is minus 100 meter, U is known, G is 9.8 meter per second square, and I don't know T. Okay, and then I can find a T, right? If I use my second kinematic equation, I would say S is equal to UT minus half GT square. So minus 100 is equal to 75 into T minus half into 9.8 into T square. Now this is a quadratic equation. So let us do this. It would be 75T minus 4.9 T square, that is equal to minus 100. So my quadratic is 4.9 T square minus 75T minus 100 is equal to 0. So by solving this quadratic, you find T. So you will get some value of T here. Okay, so many seconds. Now what do we do? See, my starting initial velocity, it is 150 meter per second, and my U cos theta, okay, so that is 150 into cos 30 is my horizontal component of velocity, and that horizontal velocity is going to remain constant. So in this much time, how much distance? I have horizontal velocity, which would be 75 root 3, and then that multiplied by this time, that will give you this distance, correct? So my R is going to be equal to my T, which I found here, multiplied by 150 into cos of 30, which is equal to root 3 upon 2. So that many meter. So the time to hit the target on ground that I got, position of the target it can hit that I got here from range. What about the maximum height it can reach? The maximum height that it can reach, that can be easily found out with our formula. So now I can have this height, right? I'll call this as h. Okay, and then that h would be equal to, it would be u square sine square theta upon it would be g, correct? That would be the maximum height, correct? Or would it be see, your range is u square sine 2 theta upon g, and the maximum height is u square sine square theta upon 2g, correct? So now you have initial velocity, you have angle of projection, and you have your g here, correct? So this distance you can easily find out. To that distance, okay, so maximum height I would write here. I'll just change the marker. My maximum height would be equal to this h that I get plus 100 meter, correct? So whatever h that you get, you have to add 100 meter to that, and then write your answer. So here the basic thing, we did very basic things, right? That we found out the time taken for this vertical displacement of 100 meter. From that time we got our range, and for maximum height, we didn't have to do anything there. There is one more question which is not actually mentioned in this problem. It is not asked. Okay, can you find the velocity with which it hits the ground? Can you find that out? See, now the thing is, your horizontal component of velocity, correct? Horizontal component is going to remain same, that is going to be u cos theta, which is equal to 75 root 3. Okay, vertical component of velocity. Okay, vertical component of velocity, what do? You can use third kinematical equation, right? V square is equal to u square plus 2as. You have your initial vertical velocity, right? Initial vertical velocity you have, and acceleration due to gravity you have. You know that my vertical displacement here, it is going to be 100 meter, correct? So you use now for this, let us call this Vy. Okay, let's call this Vy, and Vy square is equal to Uy square minus 2 into G into, I'm calling this H. Okay, I'll write this small h here. My capital H was my maximum height on that side. Okay, and this 100 meter I'm going to use small h, which I'm going to mention here. And so with this expression, you get the vertical component of velocity of striking the ground, correct? And then what is the velocity there? For velocity, you will take the vector sum of this. So your v would be equal to root over, it would be Vy square plus u square cos square theta. Okay, that would be the magnitude of velocity with which the bullet is going to strike the target. Okay, again, as an exercise, what you can do is you can find out the angle with the vertical or angle with the horizontal that the bullet is going to strike the target. Just take it as an homework, right? Thank you so much.